Hello and welcome. Today we are going to talk about Apache HBase. Let's first talk about how it started. Since 1970, the solution for data storage and data maintenance was RDBMS. The size of the database was small and RDBMS was sufficient to solve all the problems related to that. But after the advent of big data, companies realized the benefits of processing big data and hence started opting for solutions like Hadoop. Now, what is Hadoop? Hadoop is an open source framework from Apache that is used to store and process large data sets distributed across a cluster of servers. Four main components of Hadoop are Hadoop Distributed File System or HDFS, Yarn, MapReduce, and libraries. Hadoop involves not only large data but also a mixture of structured, semi structured, and unstructured information. Amazon, IBM, Microsoft, and many other software companies use Hadoop technology as for big data analysis. Now, Hadoop has some limitations. Hadoop can only perform batch processing, and data will be accessed only in sequential manner. That means one has to search the entire data set even for the simplest of jobs. The huge problem that arises from this is if a huge data set, when processed, results in another huge data set, which also should be processed sequentially, the competition and required resources for these computation and the time required increases exponentially. At this point, a new solution is needed to access any point of data in a single unit of time. Now let's come to our topic. What is HBase? HBase is an open source distributed column oriented database built on top of the Hadoop file system. It was developed by Apache Software Foundation and is written in Java. HBase runs on top of HDFS and it can store massive amounts of data ranging from terabytes to petabytes. HBase is a data model that is similar to Google's Big Table. It is designed to provide quick random access to huge amounts of unstructured data. It leverages the fault tolerance system provided by the Hadoop file system. Technically speaking, HBase is really more of a data store than a database because it lacks many of the features that we can find in an RDBMS, such as type columns, secondary indexes, triggers, and advanced query languages. Now let's come to the features of HBase. The main features of HBase are it provides fast lookup times for large tables. It provides low latency access to single rows among billions of records. It also provides atomic read and write. It is column oriented and horizontally scalable. Now let's talk about some of the deeper features of HBase. HBase is a strongly consistent read write language. HBase is not an eventually consistent data store. Whatever is processed in HBase is represented at the moment. Um, there is atomic read and write, which means that during one read or write process, all other processes are prevented from performing any operation on the database. This makes it very suitable for tasks such as high speed counter aggregation. Automatic sharding. HBase tables are distributed on the clusters via regions, and these regions can be automatically split and distributed as your data grows. This makes it linearly scalable across various nodes. And it is also modularly scalable as it is divided amongst various nodes, and we can increase the nodes to increase the data processing power. Hadoop and HDFS integration. HBase supports HDFS out of the box as its distributed file system. Some of the benefits are its support for exporting metrics with the Hadoop file metrics subsystem. Now we come to the automatic region server failover. HBase provides automatic failure support between region servers in case of any failures. MapReduce. HBase supports massively parallelized processing via MapReduce uh, by using HBase as both source and sink. HBase supports an easy to use Java API for programmatic and client access. For those front ends which do not support Java but use Thrift and REST, it also has a RESTful API. Block cache and bloom filters. HBase supports block cache and bloom filters for real-time query processing and high volume query optimization. Operational management. HBase supports built-in web pages for operational insight as well as JMX metrics. It makes it easier for analysis of these big data. Now, finally, we can say that HBase is a platform for storing and retrieving data with random access, and it has a very ideal situation for analytical processing. Now, let's come to the storage mechanism in HBase. HBase is a column-oriented database and the tables in it are sorted by row. The table schema defines only column families, which are the key value pairs. The table has multiple column families and each column family can have many number of columns. Subsequent column values are stored contiguously on the memory location. Each cell value of the table has a timestamp. In short, in an HBase, a table is a collection of rows, a row is a collection of column families, a column family is a collection of columns, and a column is a collection of key value pairs. Now let us talk about the HBase architecture. HBase architecture has three components, the HMaster, region server, and the zookeeper. The first component is HMaster. HMaster is the implementation of master server in the HBase. It is a process in which regions are assigned to region servers and DDL operations are performed on the database. It monitors all region server instances present in the cluster. In a distributed environment, the HMaster runs several background threads to handle the many DDL operation and region server fail-safe mechanisms. The second component of the HBase architecture is region server. Now the HBase tables are divided horizontally by the row key ranges into regions. Regions can be called as the basic building elements of the HBase cluster, which consists of the distribution of tables and are comprised of the column families. Region servers runs on HDFS data node, which is present in the Hadoop cluster. The regions of region server are responsible for several things like handling, managing, executing, as well as reading and writing operations on that set of region. The default size of a region is 256 megabytes. Now, the last component is the zookeeper. The zookeeper is like a coordinator in HBase. It provides services like maintaining configuration information, naming regions, providing distributed synchronization, server failure notifications, and many more. Clients mainly communicate with region server through this zookeeper. Now there are some disadvantages of HBase too. HBase does not support SQL structure since it is a non-relational database. There are also no transaction support since it runs very differently from RDBMS. The HBase records are sorted only on the keys, and since it is a very recent database management, there are also some memory issues on the cluster. Now let's talk about when to use HBase. Uh, See, Apache HBase is used to have random, real-time read and write access to big data. It hosts very large tables on top of clusters of commodity hardware. It is a non-relational database modeled after Google's Big Table. Now, keeping in mind these things, to use HBase, one first needs to have enough data. uh, if we have hundreds of millions or billions of rows, then only then HBase is a good candidate for us. If there are only tens of millions or 100,000 rows, then we can just use RDBMS and it will work just fine. Second, we need to make sure that we can live without all the extra features that an RDBMS provides. For example, the typed columns, the secondary indexes, the transactions, and very advanced query languages. Um, an application built against RDBMS cannot be ported to HBase by simply changing a JDBC driver, for example. We should consider moving from an RDBMS to HBase as a complete redesign of the infrastructure. Now, finally, we need to make sure that we have enough hardware support. Even HDFS does not do well with anything less than 5 data nodes and a name node. Similarly, HBase also needs large support from infrastructure and hardware to run properly. What are the applications of HBase? HBase is used whenever there is a need to write heavy applications and we need to provide fast random access to available data. Um, the Facebook's Messenger platform that was using Apache Cassandra shifted to HBase in November 2010, because Facebook was trying to build a scalable and robust architect infrastructure to handle the set of services like messages, email, chat, and SMS into a real-time conversation. So that's why HBase was very suited for that. Companies such as Twitter, Yahoo, and Adobe also use HBase internally. Now, HBase is suitable for online analytical processing as it is a column oriented database and it is very suitable in big data analysis. So today we learned the basic of Apache HBase, its history, its functionality, its architecture, and its usage. That's all for today's video. Thank you and have a nice day.